Hello, everybody. My name is Margherita Cumani, and I'm responsible for the Energy Efficiency Operations Unit at Hera Group. Welcome to this lecture dedicated to energy efficiency, which actually is quite a huge and very wide topic. Therefore, we will look at it focusing the consumer's point of view, consumer's perspective. This is the agenda of the lecture, or maybe I better say the flow contents that I thought useful for you to be given at this point of your professional module. So we will start with a little bit of context, trying to understand what's the role for energy efficiency in the global scenario of energy transition. We then focus two important legislative elements like the Energy Efficiency Directive and the Energy Efficiency First Principle, and then try to go a little bit deeper into the ground, trying to understand where the difficulties are and what the barriers are in preventing today the full development of energy efficiency. I'll describe you then a few good practices that usually are typical of those organizations that mostly care about energy efficiency. And in the end, a final remark on the role of energy experts and managers, energy managers today and tomorrow. Let's now begin. And I thought there was no better way to start than this 50-second video from the European Commission that I just let go.
Europe wants to be the first climate neutral continent in the world. Even though the finish line is 30 years away, the race starts now. The 2020s is the make or break decade. And that's why Europe has committed to reduce our emissions by at least 55% by 2030 compared to 1990 levels.
How powerful and how inspiring are these words from European President von der Leyen. Really, I think they perfectly set the scene for us and really give us a measure of how important and how hard is this challenge and that we have to act now. And definitely energy efficiency is part of it. Maybe we can even say that there won't be any energy transition, there won't be any carbon neutrality path without energy efficiency. Really, energy efficiency is a cornerstone, is a pillar of any possible strategy that will bring us in the next 30 years. For how much it could count for? Well, according to the International Energy Agency figures, we can say that energy efficiency could deliver up to the 35% of the cumulative CO2 savings required by 2050, which actually is quite a relevant percentage. As you can see, we can compare it with the one of renewables and see that they're not much different. So really very important, relevant, a significant part is associated with energy efficiency. The good news is that energy efficiency also contributes to other important aspects and objectives. First of all, maybe the most obvious to the reduction of the greenhouse gases emissions, because less consumption means less demand and less emission in the end, but also less need for coverage with renewables. Also, energy efficiency increases energy security because it diminishes the stress on networks, on grids, and therefore it allows the reduction of investments needed to on the supply side and infrastructures. Also, energy efficiency contributes to economic savings and economic growth, and we can see it in many ways in job opportunities, technological developments, competitiveness, and so on. And last but not least, for sure, energy efficiency contributes to social development and fight against energy poverty in terms of increased welfare and also improvement in living condition of those most vulnerable people that clearly don't have the same opportunities as other. Therefore, definitely we have a role for energy efficiency, and we also have target specifically on energy efficiency. 32.5% was the number associated with energy efficiency, and in particular, it was defined in terms of reduction of the primary energy demand by 2030. But actually, this has been already been raised in the new proposal of the Energy Efficiency Directive. Therefore, 39%, I think, should be the number we keep in mind. Let's now have a look at the European Energy Efficiency Directive, which is the main piece of legislation of reference in Europe for energy efficiency. The first version of the directive was issued in 2012, and that was for supporting the achievement of target of Kyoto Protocol for 2020. And after that, the directive was amended in 2018, and now we do have a new proposal of total revision of the directive that was issued last July 2021 together with the rest of the Fit for 55 package. This whole revision proposal has become necessary in order to adequate targets to the new increased ambition of the European Commission declared with the European Green Deal. So as I mentioned before, for example, energy efficiency target has been raised from 32.5 to 39%. So increased ambitions, increased target and measures. Obviously, this legislative piece needs to be seen integrated with other important directive. In particular, I'd like to mention the Renewable Directive, number 2, that has been reviewed as well, the Energy Performance Building Directive, and also the revision of the emission trading systems. As I said, the Energy Efficiency Directive is a very comprehensive document. We will make just a quick overview on those elements more interesting from a consumer's point of view. The new proposal of the directive addresses consumers in different ways and at different levels. First of all, as private citizens. The directive includes several elements and measures for increasing awareness of citizens and for increasing their active involvement, active engagement. These measures are aiming at making citizens more aware of what their consumptions are and where they consume energy, and more able in the end of putting in place conscious behavior. Also, there's the topic of fight against energy poverty that I've already mentioned. I see consumers as public sector. Public administration is called to play an exemplar role, and therefore it has been increased the yearly target for energy saving to be generated in public sector buildings and assets. Therefore, yes, we expect a lot to do in public administrations, buildings and assets. Last, very important for enterprises, consumers as enterprises, new definition of heating and cooling, efficient heating and cooling are provided, but also especially a point that maybe many of you are familiar with, there is new obligation on energy management systems implementation. Since I believe many of you work in the private sector, I'd like to make a focus on this point because it's quite impacting. The previous directive, there was Article 8 that basically set an energy audit obligation for all large enterprises to be repeated every 4 years. Well, now this article has become article number 11. New thresholds of consumption are defined, and above 100 terajoule per year, there's no more energy audit obligation, but there is an energy management system obligation. So it will be mandatory to implement and certify also an energy management system. And above 10 terajoule per year, energy management systems will still be the prior option, but still there will be the possibility to perform energy audits. But in that case, it will be necessary to provide evidence of having transmitted the recommendation of audits to the top management. Well, I think this is quite impacting because, as we will see further in this presentation, energy management systems implies an effort, a commitment much higher than the energy audit, but I think this is the right direction to go. Let's now come to the energy efficiency first principle, which we often hear about and to which the new directive has dedicated a full article, article number 3. What is that? What does it mean? Well, for example, it does not mean that energy efficiency must be always the priority. It's not like that. It does mean that energy efficiency benefits must be adequately taken into consideration in any policies and in any decision-making process. And why that? Because energy efficiency, if you think about it, it's kind of a first fuel, the fuel that you don't need to consume. Therefore, you always have to think about energy efficiency before the rest of options. Again, it's easy maybe to understand this principle if applied to a very easy and basic example, the one of a building, where before considering option of replacement and upgrading of the heating or cooling system inside the building, you should take into consideration improvement of the building envelope integrity, reach a better level of insulation, and so on, in order to minimize the energy demand, the energy consumption, and only after that you can think about how to replace the supply systems. Article 3 of the directive includes the need for member states to set this principle inside policies, but also to verify its application. So the message here is, as energy professional, you will be asked to provide evidences of having applied this principle in future. So really take care of this. Let's now try to translate this principle in a more complex example. In an industrial framework, let's imagine a company, an industry willing to undertake a decarbonization path. And what does applying energy efficiency first principle mean in this kind of a situation? Well, it means starting from the right point, so with energy efficiency, so minimizing energy consumption first. So considering better insulation option of building envelopes, increasing efficiency of processes, increasing efficiency of generation systems, and so on. Only after that, so having optimized the energy demand, we can consider option for replacing the energy sources with ones renewable sources with less impact on the environment. And in the second step, we might focus on those renewable systems, renewables that are already existing, options like photovoltaic, biogas, and so on. Third step is upgrading and considering a gradual conversion and upgrading of system with new emerging technology, maybe technology that are not ready yet in the short term, but they will be available in the medium term. I think about hydrogen, for example, or hydrogen-driven appliances. And yeah, that could be the third step, only after having considered 1 and 2 before. As output of the third step, we can imagine having hydrogen, for example, or biomethane as green fuels available, and we can imagine to come back to the beginning and also having increased the energy efficiency of the generation system, we could now consider the replacement of those generation system with hydrogen, for example, or biomethane. So that really completes the framework of application of energy efficiency first principle in a practical case study in the industrial sector. Okay, now that we've discussed the role of energy efficiency in the energy transition scenario, and we've pointed out the legislative framework we're moving in, we should now see the direction. We should now see clearly where to go. Unfortunately, in front of us, we don't see a downhill path. We see that difficulties are still there. Several barriers are still preventing full development, full exploitation of energy efficiency potential in companies and organizations. This is particularly true for the private sectors where companies' decisions are driven by business opportunities reasons, and this is fair enough. But I think then that focusing on what these difficulties are is necessary to move forward more effectively. And as for our experience, in particular in the private sector, we can find barriers of different kind. First of all, barriers related to trust and complication, meaning that, especially in the industrial sector, all those options and energy savings opportunities that actually changes something relevant in processes or production aspects are considered critical because they increase complexity. And so the entrepreneurs hardly would risk those aspects. And also bureaucracy connected with the incentives procedures are considered unwelcome, really unwelcome. Also, we've got barriers about knowledge, meaning that sometimes policy and support mechanisms are unknown, or even worse, they're little trust. So people, companies just don't consider them, don't take them into consideration even. And also, sometimes it's a matter of technology that are very little known, or maybe little transversal in sectors. For example, heat pumps are very well known as application in residential sector, but they do have very interesting application in industries as well, but very little known in this applications. Then we've got payback period varies on this economic aspect, and this is a very significant one. And it happens because for companies, priority is given to production and quality and normative reasons, normative aspects. Therefore, energy efficiency projects, investments very often are not considered priorities, and therefore they would be financed only if they have payback time very low, even lower than what we were expecting. And by our experience, we can say that they need to be lower than 2.5 years, which is, very, it's quite hard sometimes for them. And then the budget, when the limit is on the resources in general for financing, limit in those resources. Well, the way barriers are perceived vary a lot from company to company. You can see in this schematic here, in this pyramid, what we found to be a typical distribution for example, industries where payback period is quite an issue, whereas, for example, budget is not in itself. But whatever is the case, whatever barriers are real, perceived, they need to be addressed individually. They need to be understood and then approached in a targeted way. And we found out that these these barriers become much smaller when a company managed to change perspective. How? Well, considering energy efficiency something to be pursued together with the core business, not something parallel, not something different, not an objective in itself, for example. So energy efficiency is not a problem to be solved, but it's a resource. It's something functional to other objectives, to the core business, something that very often, for example, helps other objectives or is functional to other objectives. Yes, and what I suggest is really to try to think to our business, rethink to our business in this way, and that probably would help to make our path a little bit more straightforward. Okay, let's now move forward in what is a more practical dimension, which I'd like to describe to you a few elements that are typical of those organizations that demonstrate to have a particular attention on energy efficiency. They are good practices that are occurring where and when energy efficiency is most effectively managed. You might also take these aspects as ready-to-use tools in your organization to implement these tools, or maybe to develop further in your organization to bring value and improvement. Let's see them one by one. Okay, first of this list of good practice probably couldn't be anything but this is implementing an energy management certified ISO 50001. This is really a milestone of any effective energy management strategy, and I would define it really a must-have. But what is all about? What ISO 50001 standard? What is it? Well, the title suggests us it's about making energy a system, putting energy in the middle of the system. Let's see this image just to reach a common understanding. It all begins with top management defining a policy in which declaring its commitment in reducing consumption and improving energy efficiency in all the activities of the organization. Then, according to this policy, targets and objectives are punctually defined in a time frame, specific time frame. And number three, the most significant use of energy are identified. Their energy performance is expressed, calculated, and it's monitored continuously, pretty much continuously. In order to reach targets and objectives defined by the top management, action plans have to be implemented, and every single energy efficiency measure put in place has to be verified and analyzed and verified individually. Therefore, there's a strong strong issue in controlling every energy efficiency measure implemented by the organization. Very much attention to this aspect. As all kind of ISO standard, there is the compliance to all requirements of the standard to be proven. Therefore, the continuously activities of verification are executed. And also, yearly there's a review, an annual review of all the systems, all the process with the top management that verifies, check if the actual improvement is obtained, or if any critical aspects have occurred. The old system, you can see it as a cycle as well, actually follows the Deming cycle, plan, do, check, and act. Is oriented to the continuous improvement in terms of energy savings to be found more and more, but also energy performance to be improved, and in general all aspects related to sustainability of the system and adequacy of the system needs to be improved along the way. So what are the points of strength of this kind of approach? Well, as I said at the beginning, it's a fundamental part. There is a strong commitment at the base. Also, following this standard, the process become very much systematic, and as I said, energy is taken into consideration in all the activities of the organization. Therefore, all departments are involved in this process. For example, there are requirements in the standard related to the process of designing, for example. So you have to prove, to demonstrate how designing project or systems you take into consideration energy aspects, or there are requirements about supplying, for example, where you have to demonstrate how you take energy into consideration as a criteria to supply goods or services. In the end, you can see that energy is really a variable taken into consideration in all decision-making processes. And the result is that it's a powerful, very powerful approach and strategy in a medium-long term. Really, you can intend from this, you can expect from its application really a real reduction of consumption and real improvement of energy performance. And before moving forward, I'd like to stress how different this approach is from the energy audit, which is still accurate and still detailed, But energy audit is a process of analysis in a specific time frame and done by typically an energy auditor or an energy expert, but that it doesn't imply any commitment from the organization or any specific target to be reached. On the other hand, energy management system implies much effort, much more commitment, but turns out to be very much more effective and also oriented in a continuous improvement. Second good practice is widen as much as possible the spectrum of analysis when looking for energy efficiency solutions. So do not limit the analysis to technological aspects like equipment replacement, system revamping, innovative solution in appliances and so on. I mean, these are important, but also you might want to explore other aspects that are maybe we could define it more behavioral, that typically have very low or no investments needed, but they can produce interesting results. For example, more accurate asset management, meaning, for example, reducing as much as possible the pressure of an air compressed network, or in a group of pumpings, maybe just selecting those pumps that are best performing in energy efficiency and keeping them functioning the most of the time. I mean, giving them priority. That's an accurate asset management. But also organizational changes in production. So that is making the same thing, same product, but just in a different way, which is less energy demanding. Layout modification, and also last one, very important, working on the awareness raising of employees, technicians, designers, and operators. Let's now try to see this same set of information in an example taken from the plastic manufacturing industry. Let's say we do have different products as output, and they're different from shapes, dimension, and raw material used. What could we look at? What could be scopes of analysis, for example? On the technological side, we might evaluate changing the heat presses, for example, with more efficient appliances, for example. Also, we could evaluate an upgrading of the efficiency of the cooling system, because heat presses and also forms need to be kept refrigerated, and so the cooling system is quite energy demanding in those kind of processes. Or we might have a look at the opportunity in terms of heat recovery systems or installation of new high efficiency motors or drivers. Okay, but what about the behavioral side? We could evaluate very interesting technologies emerging that are emerging the last 10 years related to the big data and artificial intelligence application. You can see their digital optimization of the production daily scheduling, meaning there is a daily production need. These kind of algorithm and systems integrate a very large number of variables, and they find the optimum point in the production. So they minimize time waste and material waste in order to optimize the output. Also, we could evaluate improvement in control, the implementation of the energy monitoring system that somehow enable the rest of the points, and in the end, we could evaluate working on the training workers to increase the awareness of what's their impact on the energy performance. Measurement and verification. I've chosen this quote from Peter Drucker, although I know it's one of the most frequently cited ones, but It's just how it is. So you can't measure it. If you can't measure it, you can't improve it. Just to stress the importance of measurement and verification processes. They're so important because they guarantee that savings are real and not just estimation, not just calculation of experts. On a system policy level, MMV guarantees that we will have the externalities, the environmental externalities we are waiting for, we are expecting, so that the carbon neutrality will actually happen. And on a company level, we see that measurement and verification is important to guarantee that the cash flow expected will actually be generated. Bad news is that measuring energy efficiency savings is not that much easy, could be quite challenging, especially if compared with the energy production measurement, which is kind of straightforward. Generally speaking, when measuring energy savings, we've got to compare two situations, before and after the implementation. But in doing this comparison, suitable adjustments have to be done in order to guarantee that the most influent conditions and variables are adjusted and are comparable in those two situations. There are existing protocols of guidance and of reference in this field of measurement and verification. The most well-known and famous one is IEP-NVP, International Performance Measurement and Verification Protocol, issued by the International Organization EVO, an efficiency evaluation organization, and that really is very detailed and accurate and provides guidance for activities and timing that to follow when carrying out a measurement and verification process in evaluating energy efficiency measures. And just a final remark, measurement and verification is not something you can remind of in the end when everything is done, but it's something that you have to keep in mind from the very beginning, from designing and then deepening, going deeper in the analysis, and then procuring, installing, and so on. Now, a good practice I'm very keen on, the multiple benefits of energy efficiency. I want to start with an objectivity, which is energy efficiency driven investments are often disregarded because they do have payback time too high, and that happens because energy experts typically evaluate and quantify only impacts, economic impacts from energy saving. But that's not it, that's not enough. Energy efficiency never comes alone, and typically there are other impacts to be captured. And that's what multiple benefits analysis does, tries to capture all other strategic impacts in important aspects like value proposition, cost reduction, and risk mitigation. Let's have a look at it with an example. So the energy efficiency measures here in this example is the implementation of an advanced control system based on artificial intelligence for controlling and automating the heating, cooling, and ventilation systems in a building. This, of course, produces energy savings that we can see here, improvement in equipment performance. But also the new system is expected to be much more reliable and so less likely to produce malfunctioning or breakdowns, and therefore it's expected to produce reduction in maintenance costs. Not only that, also it's more precise in giving thermal condition of comfort anytime it is required, and therefore employees experimenting optimal thermal condition are more satisfied, less likely to complain, and again ask for intervention, so reduced maintenance cost again. But also there is a correlation that has been proven between optimal thermal condition and the less probability to develop respiratory diseases, and so also we expect to have an impact on reduced absenteeism and therefore improved workforce productivity. And so we managed to identify 7 non-energy benefits, and three of them have also been quantified, and they actually do change the economic results of these investments. And in particular, they're still less significant than the energy savings, but they're not negligible. Definitely, they were able to increase up to 20% the annual cash flow, and they were able to bring below the thresholds of 3 years the payback period of this investment. So my suggestion is really take the chance to experiment these kind of methodologies of analysis, and you really find it bring it value added. Now, just a final remark on the role of energy expert. Today, energy managers are very much focused on energy issues and aspects, but somehow we come back to the beginning from where we started to say that we are actually moving in a decarbonization scenario, so in a wider context where other skills and knowledges are required. Therefore, I think energy managers, as we know it today, it's a role that will need to evolve, capturing all those kind of skill and knowledge. What are they? Mainly those belonging to the greenhouse gases emission reduction field. Also very important, knowledge of the compensation mechanisms, renewables production for sure, as well as fuel switching to greener option. And also energy managers will need to know and consolidate the new technological and emerging domains like hydrogen and hydrogen-driven appliances, for example, or biomethane. And finally, I've pointed out circular economy. You might ask why circular economy, because actually energy efficiency can come from circular economy as well. For example, when starting from recuperated material or waste, you can produce the same final product with a less specific energy consumption. That's energy efficiency. So with this more complete set of knowledge and skills, I'm pretty sure energy experts of tomorrow, of the future, will be able to integrate effectively an energy efficiency improvement strategy in a wider carbon neutrality strategy. Here is just an appendix with the list, with a list of useful links. You can browse if you like, if you want to dig a little bit deeper in the topics we have looked at. And I really thanks for your attention. Hopefully you've enjoyed my presentation, and I wish you a good continuation of your professional module.